Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review what was covered in week 4. So we did two things. We did graphing polynomials and also optimization. So let's look at a graphing question here. So to graph a function like this, you need to be able to graph functions in both factorized and also expanded form. But to graph a function like this, we need to find three things. The first thing we find is the y-intercept. So to do that, you let x equal 0. So if I substitute x equals 0 into here, I get minus 4 cubed times positive 3, and I get minus 192. So that is my y-intercept. All right, to find the x-intercepts. Well, if it's in expanded form, it's lots of x's, lots of terms added together. You can use your graphics calculator to solve that. But here, because it's in expanded form, the x-intercepts are easy to find. The x-intercepts will be 4 and minus 3 because of the null factor law. If I substitute x equals 4, it makes this bracket equal 0. If I substitute x equals minus 3, it makes this bracket equal 0. All right, third, the thing that takes all our time is finding the stationary and inflection points. So to find the stationary points, you find where the first derivative equals 0. So we need to differentiate this function. Because it's a function of x times a function of x, we're going to use the product rule. So to find the derivative, we take the derivative of the first, which is 3x minus 4 squared. To get this, I use the chain rule on this function here. So derivative of the first times the second, so that's u dash v, plus uv dash, so that's plus the first times the derivative of the second. Now the derivative of the second thing is just 1. So I want to find where the first derivative equals 0, so I'm going to need to factorize this. So I have to say, common about this term and this term. What do they have in common? Well, they both have x minus 4 squared as a factor. So I write that out the front. So I need to times x minus 4 squared by 3 lots of x plus 3 to get the first term. So that will go in my brackets. And I need to times x minus 4 squared by another lot of x minus 4 to get this x minus 4 cubed. So what I'm now going to do is I'm going to expand these brackets and simplify this second bracket here. So now I'm left with f dash x equals x minus 4 squared times 4x plus 5. So where will the first derivative equal 0? Well, either the first thing has to equal 0, which means x equals 4, or the second thing has to equal 0. Now, if 4x plus 5 equals 0, subtract 5, divide by 4, you get minus 1.25. So I need to find stationary points. So I have my x value, I need to find my y value. So I substitute x back into the original equation to find my y value. So that will just give me 0, because of course if x equals 4, then it just equals 0. So substituting x equals minus 1.25 into here, I get y is like minus 253.23. Okay, so these are the stationary points. Now what I need to do is calculate the second derivative. That will allow me to classify the stationary points as maximum, minimum, or inflection, and also help me find any non-stationary inflection points. So to find the second derivative, I'm going to use the product rule on this thing here. So product rule, I differentiate the first. Derivative of the first is just 2x minus 4. Derivative of the first times the second plus the first times the derivative of the second. So the derivative of the second thing here is just 4. So once again, I need to factorize this by taking out a common factor. Here the common factor is 2 lots of x minus 4. So I took out my common factor here. I need to multiply this by 4x plus 5 to get the first, and I need to multiply 2x minus 4 by 2 to get the 4, and another lot of x minus 4 to get the second thing. So then I just expanded the brackets here, simplified all this to get 6x minus 3. So the second derivative is this. So it will equal 0 when the first bracket equals 0 or the second bracket equals 0. So these are my two values for the inflection point. So x equals 4, y equals 0. I already knew that that was a stationary point. So because the second derivative is equal to 0 here, this here is a stationary inflection point. Now, if I substitute x equals minus 1.25 into here, it doesn't matter about the answer. All I need to know is that I get a positive number. So that's because I'd get a negative times a negative. So because the second derivative is positive at this stationary point here, that means that this must be a minimum turning point. Now, at x equals 0.5 was not a stationary point, but it is an inflection point. So at x equals 0.5, I have a non-stationary inflection point. So if I substitute x equals 0.5 into my original equation, so now that I've found all intercepts, stationary, and inflection points, I can plot them to draw my graph. So I've plotted all of the points here. I have my two X-intercepts, my Y-intercept. This was a minimum turning point. This was a stationary inflection point, and my non-stationary inflection. So because I have the minimum here, what's going to happen is it's going to come down through here, hit the minimum, stop and turn around, go through the Y-intercept, and then here it's going to change. It's going to change from being concave up here to concave down there, and because this is an inflection point, it's going to turn to concave up again. And there we have the graph of x minus 4 cubed times x plus 3. All right, sorry that took a while. Let's get on to optimization. So let's have a look at this question here. Closed box with a square base. We're going to make from 4 meters squared of material. So that means its surface area has to be 4 meters squared. And we want to know the maximum volume it could have. So whenever we're talking about maximum or minimum questions, we need to find a function, differentiate, and find where the first derivative equals 0. We need to find the stationary points of the function. So during the box, we have a square base, so all sides of the base are x, and I'll just call h the height. Now, because the surface area is 4 meters squared, the surface area of this box, there's two squares that are x times x, and there are 4 rectangles that are x times h. So that has to equal 4 meters squared. The problem is here we have two variables x and h. So I'm going to get h in terms of x. So what I did here was subtract 2x squared from both sides and then divide it by 4x to get h by itself. So the reason I wanted to do that is because if I want to find the maximum volume, I need to have a function for volume, but I only want it to have one variable. You see, the volume of this box is x times h, or x squared h, but that has two variables. So instead, I'm going to rub out the h and replace it with this function here. So making this a little easy to work with, I can cross out the common factor of x. So what I'm left with on top is 4x minus 2x cubed, and I'm left with 4 on the bottom. So I times x by 4 to get 4x, x times minus 2x squared to get this, and I just have my 4 on the bottom. So just making this a little easier to work with, 4x divided by 4 is x, minus 2x cubed divided by 4 just gives me minus x cubed on 2. So this is the volume in terms of just one variable x. So to find the maximum volume, all I need to do is differentiate and find where it equals 0. So the derivative of x is 1, the derivative of x cubed on 2, so move the power to the front, decrease the power by 1, and then I keep the 2 on the bottom. So to solve where this equals 0 actually isn't too difficult. I would get minus 3x squared on 2 equals minus 1. So I've let v dash equals 0 and subtracted 1. So now I'm going to times each side by minus 2/3. What I get is x squared is 2 over 3. So x is just the square root of 2 over 3. So putting that in my calculator, I get that's about 0.816. So the maximum volume occurs when it's like 0.816 times 0.816 on the bottom. So now I'm going to substitute into here to find my maximum possible volume. So actually substituting in here would be easier. So I just went 4 times 0.816 minus 2 times 0.816 cubed over 4, and I get 0.54 meters cubed. So it turns out that actually happens if all these dimensions are the same and it's a cube. 0.816 times 0.816 times 0.816. All right, thank you so much for tuning into this video. Keep your head up. You're doing a great job. This has been the luckiest maths teacher in the world. Have a great day.